This paper one short question is a trigonometric equality to solve. So we want to find for which values of x between minus pi and pi, including both ends, sine of 2x minus cosine of 2x is the same as 1 plus sine of x minus cosine of x. There are many ways to solve this, but I think the first thing that you will notice is that on the left-hand side we have double angles, so it's going to be useful to use the double angle identities to write everything on terms of sine of x and cosine of x. So let me write over here, instead of sine of 2x, we can write 2 times sine of x cosine of x. This is in the formula booklet. And instead of cosine of 2x, well, we have many options. I'm going to go for the one that says that this is equal to 2 times cosine square of x minus 1. The reason why I choose this one, and as I say, this is not the only way of doing it, is because when I have a minus in front of the cosine of 2x, that means that this minus 1 is going to become plus 1. So I'm going to have plus 1 on the left-hand side and on the right-hand side. It's over here. So I'm going to be able to cancel that. So what we are doing, first of all, is substitute the double angles for just things in terms of sine of x and cosine of x, and simplify that expression a little bit with cancelling of a 1 that is summing over there. So we have 2 times sine of x times cosine of x minus, I'll use brackets, 2 times cosine square of x minus 1. This is equal to 1 plus sine of x minus cosine of x. So applying distributive for the bracket we have on the left hand side, we have 2 sine of x cosine of x minus 2 times cosine square of x plus 1 equals 1 plus sine of x minus cosine of x. So here's where I say we cancel the ones on both sides, and we are left with 2 sine x cosine x minus 2 cosine square x, and I'm going to move everything to the left hand side. So minus sine x plus cosine of x is equal to 0. You may notice that there is a common factor cosine of x and common factor 2 between the first two terms, so I'm going to factorize that. 2 times cosine of x times sine of x minus cosine of x. This goes for the first two expressions, first two terms we have here. And then minus sine of x plus cosine of x is equal to 0. You may notice that we almost have another common factor to take between the first term and the other two. We have sine of x minus cosine of x on one side, and on the other we have minus sine of x plus cosine of x. So we need to change the sign in the second part. So I'm going to write that 2 times cosine of x times sine of x minus cosine of x minus, so if I take minus 1 of common factor, I'll be left with sine of x minus cosine of x, and that's what we wanted to get. So now we have this common bracket between the two terms, so we can go further and totally factorize the expression. So sine of x minus cosine of x times, from the first term we have 2 times cosine of x, from the second we have minus 1 is equal to 0. So let's go back 1 second. What did we do? We used the double angle identities and we rearrange a bit, simplifying these plus 1s we had over there, and then we factorize our expression. And now that the expression is factorized, we use the null factor law to say that the two options for the expression to be equal to 0 is either that sine of x is equal to cosine of x, or the other option is that 2 times cosine of x minus 1 is 0, which means that cosine of x is equal to a half. So we are looking for values of x between minus pi and pi, including the endpoints, that verify either the first or the second of our equalities, and this we know how to solve. For instance, the first one. Let me draw a unit circle over here, even if it's a little bit ugly. Well, we want sine to be equal to cosine, so that means we need to be in the line where the y and the x coordinates are equal, so in the line y equals x. So that means that it's good for us either this angle over here, which is pi over 4, or we could go around here, pi plus pi over 4, but that's not good for us because our interval is between minus pi and pi, so that's not going to help us. But we could go to the negative side, so we could go clockwise, and we have over here minus 3 pi over 4. So both of those angles give us the value of sine of x to be equal to the value of the cosine of x. So from here we get two possible solutions in our interval. Either x is equal to pi over 4 or x is equal to negative 3 pi over 4. That's for the first factor. For the second factor, we want cosine of x to be equal to 1/2. Again, I need a unit circle, even if it's not a very pretty one, doesn't matter. So we want to be in this line, in the line x equals 1/2, because we want the x coordinate to be 1/2. So here what we have, well, we have this angle over here, and we also have minus that angle. So what is that angle? Well, we can go back to the equilateral triangle with sides 1. So this angle over here is pi over 3. And then we bisect this triangle, and we get here a side that is a half. And then when we try to find what is the cosine of pi over 3, cosine of pi over 3, that's going to be equal to adjacent, which is 1/2, divided by hypotenuse, which is 1. So this is 1/2. So cosine of x is equal to 1/2 for x equals pi over 3, according to the triangle, and according to our picture of the unit circle in our interval. This is also true for x equals minus pi over 3. So here there are the solutions we got. We got here x is equal to pi over 4, or x is equal to negative 3 pi over 4, or we can have x equals to pi over 3 or to negative pi over 3. Sorry, here I wrote something wrong. And those are all the solutions for our equality. We don't have a calculator for this paper, so well, we cannot take a graphical approach, but well, we solve it anyways.